Welcome everyone to the beginner's guide for open materials on the Stratasys 3D printers. It's pretty exciting. This is something that I honestly didn't know I'd ever see. So just a little bit about me. I'm Joseph from the northern part of Georgia, just outside of Atlanta. I've been an application engineer working with Stratasys 3D printers for about 14 years. I love reading and painting, and when I'm not doing either of those, I'm hanging out with my family. But 3D printing has been a huge part of my life so far, and this is really exciting news to share what Stratasys is doing now. Just a quick note of GoEngineer. We are the #1 technical resource for SolidWorks and Stratasys. We specialize in everything to get your product through the design and prototyping phase, even into a little bit of manufacturing if you're using additive as your manufacturing process. SolidWorks, 3D scanning, 3D printing with various technologies, Stratasys, of course, Velo, and even MakerBot and Ultimaker now that they've merged. So a little bit about GoEngineer. Oh yes, and our huge array of offices across the nation now. Just a bit about us. Now we'll jump into this. I'm gonna stop my little webcam here so we can focus on this material. We're gonna cover what are the preferred, validated, and open materials from Stratasys. Currently, this is only offered on the Fortus 450, but we hope that they'll open it up onto more systems. I have heard from Stratasys that they are definitely planning on adding the 900 to these different material classes, but when that will happen, we don't know for sure yet. Hopefully in the next year or so. So why did Stratasys give these different material classes? Well, frankly, it's just so they can get more materials out to you more quickly, okay? We'll start with the preferred materials. This is everything that you're used to seeing on Stratasys up until the end of last year. So your ABS, ASA, polycarbonate, ULTEM, your standard materials from Stratasys. These have all been rigorously tested and verified. Their production is regulated. They go through years of configurations and testing to make sure that they will print reliably. This is what really slows down the time it takes to get new materials on Stratasys printers. It's just a long process. We usually only see a new material every couple of years because it takes so long. Not only are they testing it on a single printer to get an idea for it, but once they kind of narrow down what they're doing, they then have to test it on multiple printers. So it really slows that process down. But they added now the validated materials. So these are sourced through Stratasys as the preferred materials have been, but they don't go through as such rigorous testing process. And because of that, they can come out much quicker, and especially now that they've purchased Covestro, who makes plastics, we hope to see a lot of new and fun materials coming through them. Just a quick overview of the validated materials, since our purpose here is the open materials, just so you get the idea of what's needed. It is currently only on the Fortus 450. You do need to have the all material license and the hardened head upgrade. It's kind of an all or none thing for the validated materials. And then also to put up with some small imperfections because they're not as tested as rigorously as the preferred materials, but they do become available much more quickly. The current validated materials are some ULTEM 9085 colors, more than what they currently have, a few peaks and nylons and PCs, even PC ABS in colors, and a new HIPS material. We're going to jump through these just real quick, just to give an idea of what they are, and jump into the open materials next. So PC, PCABS, and ULTEM 9085 are coming out in new colors. The Kimya is a really interesting polycarbonate, a flame retardant polycarbonate. It was designed for rail and has passed a lot of the NFPA 130 and other flammability tests, so it can be used in public transportation. It behaves a lot like the current polycarbonate and uses the soluble support, which allows for great design freedom. The Adigy has a really long designation, the PA666GF20LSFR. It's a mouthful, but it's kind of a cool material. It's a nylon 6 with a 20% glass fill that also has low smoke and flame retardant properties, also designed for public transportation needs. They say it has a superb raw surface finish right out of the printer. This example part looks pretty good. I just got some in myself, and I'm excited to print with it and see how it really looks. I'll be giving a review on that sometime soon. It is a breakaway support material, which means you do have to keep that in mind in your design and printing. You can't just dissolve any support material out, so just to bear that in mind. Vitrex, this is an impressive one. It's a low melt PEEK material. PEEK is kind of a tough one for additive. Stratasys has had PEEK in the past, and it worked, but it was a chore to work with. So this one is strong, chemical resistant, has low outgassing for fire, and you can anneal it to give it even more strength. But you can also print the SR100 soluble support with it, giving incredible design freedom for this new material. I'm really excited to see what we can do with this. Again, for aerospace and public transportations, or just you need a really strong part. PEEK and PEC materials are very strong. And last is the HIPS. This is a high-impact polystyrene. This is a less expensive even than the ABS. It's just a really good kind of first draft material, give you something to work with in your design development. But it only has the breakaway support, so also need to bear that in mind when designing and printing with it. But for kind of a draft material, this will be really, really good. All right, before we jump into the open materials, do we have any quick questions before from the preferred and validated materials? Here's one. I work on the Stratasys FDM materials production team and want to clarify that some of the validated materials can run both on the hardened and non-hardened head. Oh yes, thank you. Thank you, Thomas, that is good. The PC can run on the non-hardened. Okay. Excellent, thank you, Thomas, that's great. All right, into the open materials. What is open materials? Well, it's very much what it says. You can use whatever material meets your needs. These are not sourced from Stratasys. You'll have to pull these from wherever you can find them, whatever's going to meet your needs. So you have no testing, no support from Stratasys on running these. You can even make your own material if you've got something really specific you need to run. But there is zero help from Stratasys as far as how to configure a specific material. They'll gladly give help on clarifying some points or whatever they can do, but they're not able to sit down with everyone and help the entire process front to back of tuning and calibrating a specific material. GoEngineer will provide some help. Myself and a couple of other of our application engineers are going to be focusing on this quite a bit, and we'll be able to give some pointers and guidance. But even then, most of this process, cards on the table, most of the process for running an open material is you're going to have to figure it out as you go. Luckily, the documentation that Stratasys provides for it is pretty good, and I'll get into that in my experience here in a few minutes. Okay, what is it not? Open materials is not just a free pass on cheap materials. Okay, that is not the point of it. That's not what Stratasys is trying to do with this. It's intended to be a method to help customers get the materials they need for their products more quickly than Stratasys can do just on their own through their normal verification and product testing that they do. So not just to use cheap materials, it's to help get good stuff. So because of that, who is open materials for? That's definitely focusing more on research and development. Education is a good one. Anybody working in a graduate level program to play with new materials and new additive manufacturing techniques. That's a wonderful tool for them. Customers who have very specific custom material needs, things that Stratasys does not offer yet, this is the way to get them. If you're developing new polymers for 3D printing, you can also use the OpenAM software to fine-tune preferred or validated materials. So even the standard ABS from Stratasys, you can open that up in the Open Materials software and fine-tune it for your specific printer. As they go through the process of fine-tuning all of the print parameters, they run it on multiple printers and find the best settings to run on the most printers. So you could fine-tune this even closer for your specific printer. I would only really do this for end-use parts as listed here. So if you're using additive manufacturing for your product and that's what's making you money, it might be well worth fine-tuning that to your printer. What do you need to make this work? Well, you need the OpenAM license for the printer. You need the OpenAM software, and those two come together. You need the OpenAM heads. Now, they're doing this because there's no warranty on the open heads. Because, again, you're assuming some of the risk for tuning a third-party material. So they don't want to have to keep replacing print heads under warranty for tuning errors and things. Why? Well, they could answer that better than me, but that's what they're saying. You use the open heads for third-party materials. You can reuse the old Stratasys canister. So just open up an empty canister and put in your new custom material. I would only do this for a while. Wouldn't want the seals to get too old on those, but you certainly can just reuse those old canisters. You do need to get the chips, the EEPROM memory chips for each canister. This is how the printer knows what material you're installing into the printer. They have generic chips for this open materials. The OpenAM software, this is the print parameters management tool. You can control almost everything about printing with these. It's really neat. You use this to tune all of this print settings, temperatures, extrusion rates. There are dozens of settings on this. And because of that, you can really dial in how the material prints on your specific printer even. It also generates the information for the print parameters for your printer and for the GrabCAD print and Insight slicing software. So it can even know what you're dealing with, especially if you're running a custom material, it will need to know what you're working with. Just again, you can fine tune all of these, even for the preferred materials if you find that need. But definitely leaning towards the custom materials and open materials for those custom needs or research, right? A quick glance at it, you can see there's quite a few adjustments. Now this is just under one tab, the temperatures, the support temperatures, all of those things. One of my favorites is you can adjust the extrusion rate when it goes around a corner. It's pretty detailed. There's a lot you can come in and play with this. And so the process you go through with the software, after you get the software, the licenses and the software, and you get that installed, then you can choose a base material starting point. You see at the bottom of the list of those software or of those materials, there's structured generic materials. So not only the ABS and the peaks, but if you are working with a custom material that falls kind of into one of those categories, that can be a good starting point for you. Then you go into the tuning portion of it and tweak all of those settings. Once you have that done, then you create a set or a group of those parameters and allow that package to be compiled. It sends it back to a server and compiles that. And then you get back the upgrade packages for the printer and the software. Put your printer into upgrade mode, run that update, and then the printer and your slicing software is ready to go and work with those new materials and new configurations. Run some test prints and repeat that as needed. Pretty straightforward, but it takes some doing. The hardware process. You need the hardened head, the printer license, or sorry, not the hardened head, the open head. Install all of those components and then put the head in and load up the material into the canister and replace the chip to the Stratasys chip. It seems kind of like a lot, but honestly, for me, that's the fun part. A quick example case. I've only had this for a few weeks myself and have started playing with it. So I got an ABS, a glass-filled ABS that I could play with a little bit, put it into the OpenAM software, tweaked a couple of the settings that made sense to me, working with a filled material, and then I ran a test print. And I'm going to repeat that to get some fine tuning here in the next couple weeks. So just a simple part just to do a little bit of testing with. The part on the left is my benchmark part. This was just Stratasys preferred material, so I could compare to my new glass-filled material. And on that little box, you can see that the one on the left, my baseline, is right where I'd expect it to be. Just a little bit off from dead on, well within the printer specs. And then my new material is quite a bit wider. So it's over extruding a little bit, whether that's just in the flow rate or the temperatures. Is it more viscous? Is it the glass fill in it? Those are all the types of things I'll need to consider as I continue to tweak and play with the settings on this to fine tune the material. So what I've learned so far, first, read all the instructions. Like I said before, I kind of got a little bit of expert blind spot going. I let myself think, oh, I've been doing this for 10 years. I know what I'm doing. True, but I had to come back and read the instructions, and I found the spot that I had messed up. So this is new stuff. Definitely recommend reading all of the instructions that come with the licenses. And I highly recommend doing like I did. Start with something basic, something that's really close to what you're already used to working with. And then make some tweaks and changes on that. Learn the process on something simple. That will allow you to understand what's going on, how the software works, and all of that will allow you to become familiar with the software and the process. So then when you start working with the material you really need, you really want, that custom material, then it's not going to be so confusing to you. You'll have a roadmap to follow. Physical changes were really the easy part. And then definitely work on multiple testing. As I said, I've just started playing with this new material myself. I have a long way to go before I can say it's totally done. So, but it's been a really fun journey. I've really enjoyed it. I was at the Rapid show last week, and one of my main goals there was to see what materials were out there, what other materials could be used. And I had a good idea on most of these, but some of them were surprises, even very pleasant surprises. I've had a lot of customers asked me over the years for polypropylene, And even the polygets, they can mimic polypropylene, but there was no polypropylene that I knew of. And I found a polypropylene. So that'll be really fun to get in and play with. Some bio-based materials, some biocompatible materials, recycled materials, even some people testing conductive 3D printed materials. So there's a lot out there without having to even just straight up create your own material that could fill some needs in your additive processes. Now on to the bottom line, so to speak. What are the costs involved? Well, first, the material cost, and that will come down to whatever you find and whatever that cost is to get the material in. The OpenAM licenses and software is either a $12,000 annual price or an $80,000 perpetual license. The OpenAM heads, there are a couple options, and you do need to have the hardened kit installed in your printer also to run many of these. That will come down to what packages you need, what material licenses you need to get to the all materials licenses. So that one, reach out to your sales representative to figure out any of those prices specifically for your needs. The canisters are $75 from Stratasys, or you can reuse what you have. Like I said earlier, you will want to get fresh canisters every now and then, as the seals, the orange seals on them, eventually will dry out and crack and not keep out the moisture from them. And then the chips are $60 each. There are 3 temperature ratings for those chips, kind of the low temperature ABS, then the middle range nylon and polycarbonate, and then the high temperature chips for Ultems and such. And those come pre-programmed with 90 cubic inches of material on them. So if you load up less than the 90, something to bear in mind, you're going to have to keep track of the usage on it yourself so you don't run out without the chip being aware of it, right? So those are the main costs involved with getting up and running the OpenAM. So because of those costs, that's another reason why this isn't just I want to spend less money on material and buy third-party material. To get up and using this open system, there is some fees involved with that. So, all right, those are the basics and everything I've learned so far about the OpenAM 3D printing on the Fortus 450 from Stratasys. I'd love to take some more questions. Got another one from Thomas. What tip did you use when printing your glass fiber-filled ABS material? That one, I just used a standard T16, probably not the best tip to use for it, but I wanted a solid baseline from something I'm completely familiar with. I did debate on using the hardened tip, like the nylon 12s CF, but I chose to start straight comparison apple to apples and then go on from there. I will probably want to use a hardened tip. I'd just like to thank you all for joining me today and letting me share what I've learned. It's been really fun. I look forward to seeing what other materials we can use and fun things to create. All right, well, if you do have any questions, please feel free to reach out to us at GoEngineer or myself, and we'll be happy to help you out with any of those questions and even see if this would be a good solution for some of your additive needs. Thank you all for joining me today. I look forward to seeing you in the future. Oh, I did get one. Oh, great job. Thanks, Tom. All right, bye-bye.